Descartes' rule of signs, guys. A lot of words here. By the way, don't say Descartes because the S's are silent. Make sure you say Descartes because you want to sound smart. Because if you're talking about Descartes, you are smart. He's a philosopher also. Basically, he figured out a trick to figure out the number of possible signs for zeros. So, remember, you can have positive zeros. Positive zeros cross the x-axis on that side of the origin. Let's pretend the origin's right here. Positive x-axis. Then you can have negative zeros, which are on this side of the origin. And then you can have zeros that don't ever cross any x-axis because they are what? Imaginary. Good job. So that's what we're going to be dealing with. But here's what he figured out. If you have a regular polynomial, every time it flips signs, like from positive to negative, that total number is a possible combo of positive zeros. For example, we have 2x to the fourth minus 17x to the third plus 35x squared plus 9x minus 45. So it flipped from a positive to a negative right there. That's one change. Then it flipped back to a positive. That's another change in signs. Then it stayed. But it flipped one more time from a positive to a negative right there. So the answers to this polynomial has 3 variations in signs. So I'm either going to have 3 positives or, what's 3 minus 2? 1 positive. And I'll tell you why I asked you why we were subtracting by 2. Which means, guys, if I put this in Desmos and graphed it, it's going to cross the x-axis 3 times over there or 1 time. Not 2 times, not 4 times. It's certainly going to cross it, but we just don't know if it's 3 or 1 yet. All right, on the flip side, not only did he discover that, he also discovered you could figure out the negative x-intercepts if you plug in for negative x, which is what we're going to do down here. So let me move this up to make sure everybody can see. All right, so when we plug in negative x, remember anything that has an even degree is going to stay the same sign. Anything that has an odd degree is going to change signs. So when we plug in negative x, a couple of things changed. The 17 changed and the 9 changed because they both had an odd degree. Now let's look at the change in variation. So positive, positive, oh, there it goes. There's a flip. And then that's it. So when we plug in negative x, the polynomial has 1 variation in sign. Which means you're going to have 1 negative answer. What's 1 minus 2? Oh, we're talking about possibilities, so we don't need any negatives. So, here's what I know for sure, absolutely for sure, safe bet. I know that this polynomial has 1 negative x-intercept. I know it does. I don't know where it is, but I know for sure it crosses the x-axis once that way. That's what Descartes' rule of sign is. That's all it is, guys. So here's where Ms. Harrington gets a little extra, right here on this line. If we worked out the whole problem, we are going to find the factors are, we are going to work out the whole problem. I'm going to give you some information. Don't get upset. This is fun. I am going to tell you one of the factors are, and I'm sorry, I don't remember. Hold on a moment. One of the factors are x plus 1. And another factor is x minus 3. I'm giving you that information. I already worked this problem out. I'm giving you this information. So if these are factors, then we are going to solve the problem. How are you going to use those factors to start breaking down this giant polynomial? synthetic division. Let's do it. All right. So I'm going to plug in a -1 right here. I'm going to draw an upside down division box. And I'm going to plug in all these numbers. Kind of write small because I didn't really leave room. Now remember, if x plus 1 is a factor, what should be the answer right there? Good. And guys, if you go ahead and do that, bring down your first number. And if you guys just want to copy this for the sake of time, I'm totally cool with that. I've been doing this all day. I have it memorized. 35 plus 19 is 54. That's going to be a -54 when we multiply it by that -1. 9 minus 54 is -45, and -1 times -45 is a positive 45. All right, cool. So we divided, we got 0, we're ready to roll. Guys, what was the degree of the original polynomial? 4. So what is the degree of that? 3. Keep that in mind because we're not done. I'm not even going to write the quotient. I'm just going to use these numbers and do fake division again with that other factor. So now, let's plug in a 3 and do synthetic with those brand new numbers. We should still get 0. So again, guys, I've been doing this all day. It's cool if you just want to look at mine. So I brought that 3 down. That's a 6. 19 minus 6 is -13. 3 times -13 is -39. 54 minus 39 is a positive 15. And then 3 times 15 is 45, which is a 0. So let me make sure we're all good on factors. If x plus 1 is a factor for this big giant polynomial, it's a factor for all the babies. If x minus 3 is a factor for this big polynomial, it's a factor for all the babies. However, when you go to do synthetic division, notice how I use -1 right here. And when we divide it again, you can't use -1 again. Every time you divide, you have to use a different factor. You can't repeat the same one. All right, so that was a degree of 4. That's a degree of 3. What is this red a degree of? That's a quadratic. See if you can factor it. See if you can factor this quadratic. You can factor that, by the way. Guys, what are the factors of this? The one with the 5 is a -2, x minus 5? They're both minus. Okay, good. All right, so all those factors, we're going to recopy right there. We worked it out. I didn't spoon feed you that. You found all the factors yourself. So we're going to recopy x plus 1 and x minus 3. Let's put them all in parentheses. So x plus 1 was a factor. X minus 3. You found the other two factors. 2x minus 3. And then x minus 5. All right. So we've completely factored it. Completely. We broke that all the way down to linear factors. You cannot go any lower than that. Those are x-intercepts. How many positive x-intercepts do you have? That's right. Anything that's negative in parentheses is a positive x-intercept. So we know that we have 3 positives, which we knew we would either get 3 or 1. We ended up with 3. There's 3 positives. And we knew how many negatives we would have. Guys, how many plus signs are in here? How many negative x-intercepts do you have? But we knew that because we just did Descartes' rule of signs. So remember we had a total possible of 4 zeros. I knew that was possible because of the degree. We ended up with 3 positives, so it crosses the x-axis 3 times over there. 1 negative x-intercept on the other side. Thanks, guys. You're going to be given a polynomial. And the leading, we're going to reinvent spelling. We're going to spell leading coefficient like this. Leading coefficient. Remember, the leading coefficient is the number in the front. Then you're going to have blah, 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 all this other stuff in the middle of your polynomial, x to the 4th, x to the 3rd, negative 2x squared, whatever. It doesn't matter for this. All that matters is the first term and the last term, which we call p. So q is the first term. The stuff in the middle doesn't matter. P is the last term. So remember, we're going to look at P and we're going to find all the factors that make up P. We're going to look at Q. We're going to look at all the factors that make up Q, and those are going to be the combinations for real answers. Let me show you guys what I'm talking about. I'm going to go down to this example right here. P is the constant. P is the term at the end. Which term's at the end? Negative 3. Right, negative 3 right here for P. And then draw a colon because we're going to break it down. Q, what's the leading coefficient? What's the leading coefficient, y'all? 1 is right. Let's write 1. Draw a colon, and we'll come back to that. All right, back to negative 3. What are all the numbers that multiply and make 3? That's it, just 1 and 3. So we're going to take 1 and 3, the positives and the negatives. We want positive 1, negative 1. Positive 3, negative 3. What are all the numbers in the universe that make 1? That's right. So just write positive and negative 1. So the way we're going to figure out the actual possible answers is we're going to do P divided by Q. So we're going to do 1 divided by 1, which is 1. 3 divided by 1, which is 3. And that's it. But it's positive and negative. So you have a total of 4 possible answers. Can't have a 2. Can't have a negative 5. Could have a positive 1. Could have a negative 1. You will have one of those. It will be one of those. All right, let's take a look at 13 and do it again. So for problem 13, we need P, which is the very last term, which is 1. We need the leading coefficient. Co sounds like it could start with Q sometimes. Leading coefficient is 3. Now, the only numbers that multiply together to make the P value are 1. The only numbers that multiply to make the Q value are 1 and 3. P divided by Q. 1 divided by 1 is 1. 1 divided by 3 is 1/3. And we want all the positives and all the negatives. Those are the only answers for that. So, honestly, I think that these classwork examples, again, these are like no room to show work, so I'm going to do the best I can. On number 20, guys, we're going to do the P divided by Q. On number 20, what is the P? 6. Yes, what is the Q? Negative 4. So, for P, write plus and minus. You're always going to have a 1 for P and Q. What are all the numbers that make up 6? Let's list them in order. 1, then what?
2.
2, then 3, then 6. And then what are all the possible numbers for Q? 1, 2, 4. That's it. 1, 2, and 4. All right, now, let me see if I can make this a little bigger. Nope. Now what we're going to do is we are going to find all the possibilities when I go back and find columns. Just wanted to see if I can make that a little clearer. Okay. So possible answers are P divided by Q. Don't write any repeats. So we're going to take 1 and we're going to divide it by all of these. 1 divided by 1 is 1. 1 divided by 2 is a half. 1 divided by 4 is 1/4. Then we're going to do 2 and divide it by that again. 2 divided by 1 is 2. What's 2 divided by 2? I already have that. I'm not writing it again. What's 2 divided by 4? 1/2. We already have it. Don't write it again. Now let's do the 3's. 3 divided by 1 is 3. 3 divided by 2 is 3/2. I'm already writing in the wrong answer blank for 21. 3 divided by 4 is 3/4. Now let's look at 6. 6 divided by 1 is 6. Y'all, what's 6 divided by 2? Are you going to write it again?
No.
What's 6 divided by 4? Do you already have that? That's it. So guys, that